New Syllabus Mathematics Book 2, Exercise 1A, Question number 4. If Q is directly proportional to P and Q equals 28 when P equals 4, first part from the question is to express Q in terms of P. Second part is find the value of Q when P equals 5. And the third part is calculate the value of P when Q equals 42. Now, according to the statement of the question, this first quantity Q is directly proportional to the second quantity P, which means that if first quantity increases, then the second quantity will increase. And if first quantity decreases, the second quantity P will decrease. So I will start from this statement. Since Q is directly proportional to P, so this statement can be written as Q is directly proportional to P. Okay, I will place constant K while removing this sign of proportionality. So this equation becomes Q equals constant K P. Okay, now let's find the value of constant K by putting these two values of Q and P in this equation. So when P equals 4 and Q equals 28, then this equation Q equals constant Kp becomes 28, which is the value of Q, equals K multiplied by P, which is 4. Since we are finding constant K, so let's take this 4 to the left side of this equation. Then the fraction becomes 28 upon 4. Okay, 28 is the multiple of 4, which means 4 times 7, 28. So the constant K equals 7. Therefore, the required equation Q in terms of P can be written as Q equals 7P. Now 7 is the value of this constant K. So this equation becomes Q equals 7P. So this is the solution for part A. The second part from the question is to find the value of Q when P equals 5. Okay, we have given the value of P, which is 5, and we have calculated the value of constant K, which is 7. So by putting these two values in this equation, Q equals Kp, we can find the value of Q. Okay, when P equals 5, which is given in the statement of the question, then again we know that Q equals constant Kp by substituting these values in this equation. So Q equals K we calculated, which is 7, multiplied by P is given in the question is 5. So by taking the product of 7 and 5, their product is 7 times 5, 35, which is the required value of Q when P equals 5. And our third part from the question is to calculate the value of P when Q equals 42. So again we will be using this equation because these two quantities Q and P are in direct proportion. So again when Q equals 42, which is given in the statement of the question, this equation Q equals Kp becomes 42, which is the value of Q, equals 7 multiplied by P. Now 7 is the value of constant K, which we have calculated. Okay, to find the value of P, I will take this 7 to the left side of this equation. Then this equation becomes 42 upon 7. And 42 is the multiple of 7, so 7 times 6 equals 42. This is the value of P. So therefore P equals 6. Next, question number 5 from this exercise, find the cost of 10 kilogram of tea leaves when 3 kilogram of tea leaves cost $18. And the second part from the question is A kilogram of sugar when B kilogram of sugar costs C dollars. Okay, to solve first part from the question, the mass of tea leaves is directly proportional to the cost of tea leaves. Definitely this thing is given in the statement of the question. So cost of 3 kilogram tea leaves is $18. So to find the required cost of 10 kilogram tea leaves, first of all we will be finding the cost of 1 kilogram tea leaves. And this can be calculated by 18 divided by 3 which means 3 times 6, 18 equals $6. So if the cost of 3 kilogram of tea leaves is $18, then the cost of 1 kilogram tea leaves is $6. Now if we multiply 6 by 10, it means that we are finding the cost of 10 kilogram of tea leaves. So the cost of 10 kilogram tea leaves equals 6 multiplied by 10 equals $60. So it is clear that if the cost of 3 kilogram tea leaves is $18, then the cost of 10 kilogram tea leaves will be $60. Because these two quantities, the mass of tea leaves and the cost of tea leaves, is in direct proportion. Second part from this question is to find A kilogram of sugar when B kilogram of sugar cost C dollar. So just like first part from the question, in the second part, the mass of sugar is directly proportional to the cost of sugar. So we know that cost of B kilogram sugar is C dollar. So let's find the cost of 1 kilogram of sugar, which can be written as C upon B. Okay, now after this fraction, let's find the cost of A kilogram sugar. So simply we will multiply this variable A by this fraction C upon B, just like we have done in the first part of the question, where we calculated the cost of 1 kilogram of tea leaves and then cost of 10 kilogram tea leaves by taking the product of 6 and 10. So here we have fraction C upon B. To find the cost of 1 kilogram of sugar, I will multiply A by this fraction C upon B. Finally, the product is C times A equals AC upon B, which is the required cost of A kilogram of sugar. Question number 6 from this exercise 1A is 5 upon 9 of a piece of metal has a mass of 7 kilogram. What is the mass of 2 upon 7 of the piece of metal? Once again, amount of metal is directly proportional to the mass. So first I will write the statement. 5 upon 9 of a piece of metal has a mass 7 kilogram. So a whole piece of metal has a mass can be written as 7 upon 5 over 9. So after finding this whole piece of metal has a mass 7 upon 5 upon 9, let's find 2 upon 7 of a piece of metal has a mass, or we will write this fraction 7 whole upon 5 upon 9 multiplied by 2 upon 7. Okay, and now 7 multiplied by 5 upon 9, we are expressing, or we are converting this fraction into multiplication. Then we know that we will be taking the reciprocal of this fraction 5 upon 9, which is 9 upon 5. So 7 multiplied by reciprocal of this fraction 5 upon 9, which is 9 upon 5, multiplied by 2 upon 7 as it is. We are changing this fraction, this division, into multiplication. Then we'll be taking the reciprocal of this fraction 5 upon 9, which is 9 upon 5. So here we have some simplification, like cancel out 7 by 7. And then let's take the product of 9 and 2, which means 9 times 2, 18 upon 5. 18 upon 5 is an improper fraction. So if we divide 18 by 5, so we can express our answer in the form of 3 whole 3 upon 5 kilogram, which is the required mass of 2 upon 7 of a piece of metal